us all the way from Israel. We're inviting Dr. David Bodov from the University of Haifa. Oh, happy Rosh Hashanah, David. New Year, new beginnings. Professor Bodov is the head of research at Core AI. He was previously professor at the Hong Kong University of Science and Technology, as well as the Seoul National University. He's also worked with eBay's Big Data Lab. So let's welcome Professor Bodov to talk about how we deal with biases in AI.
Thank you, Al. Can you all hear me okay?
Yes.
Okay, great. So in the general rubric of ethics and AI, I've chosen to pick off one particular piece, dig in a little bit, bias in machine learning. I've chosen machine learning as the part of AI to dig into because it seems to be the most widely used already. It's not futuristic, it's in very widespread use. So this talk will be a little bit nitty-gritty if I manage by time. I purposely wanted a nitty-gritty talk to convey to the audience that a sort of positive, hopeful belief. I believe that this work of ethics and AI is going to get done. And it's going to get done by a lot of little itty-bitty work, technical small steps being guided by profound thoughts. But I'm hopeful. I wanted to just share with you a little bit some examples of the nitty-gritty work that's being done. Just for those of you who may not know, when we say machine learning, it really means machine learning from examples. That's how the machine learns. Now, the two kinds of things that machine learning does in the world is, we call them classification, classifying things into categories, and prediction. Well, that might not strike you as very much. My job, both as a business school professor and in my consulting work, is to identify in companies and in society where humans are doing something that's kind of like classifying or predicting, so that then we can enter with our machine learning. And I want to tell you that job is quite easy. The reason is you can't imagine how much of what a person does actually is classifying and predicting, or certainly a lot of the interesting things that we do. So just to share a few examples, this is not tomorrow or even today, this is yesterday. Machine learning, classification, and prediction algorithms are affecting our lives already now in very big ways. They will determine whether you even get an interview for a job, or if you get the job, if you're approved for a loan, what kind of treatment, first of all, what disease do you have, what kind of treatment you're going to get, if your boxes or baggage at the airport is inspected or not. And one more, so this is just small points, whether you get a job, whether you get a house, what jobs you're even aware of. All these things are decided by machine learning. Now, all they're doing is classification problems and prediction problems, but you must trust me, this stuff is everywhere. I realize people that are in this webinar already know that this is a big topic. I think we really don't even know. This is affecting everything, large parts of our life. The most interesting point I want to make, actually, I couldn't resist because we have some big thinkers in the audience here today. I want to say one comment that is not getting enough attention. During Corona, during the lockdown, by the way, Israel is going to lockdown again today. I've been watching Netflix. There's a series on Netflix where a woman travels back in time. And you know all the ethical dilemmas the name of the series is Outlander. You know the ethical dilemmas that arise when you travel back in time. You're bothered because you already know the future, and then can you change the future? This sounds like a science fiction-y type thing. We are there. Machine learning prediction does the same thing as time travel. Why? Instead of traveling back in time, machine learning allows us to see the future. Now, let me give you an example. When you arrive at your first day at a new job, they run a machine learning algorithm, they know how long you're going to stay there, if you're likely to get ill during your tenure at that company, what's the last position you're going to achieve at that company, will you ever make it to vice president, or will you retire at one level beneath as a project manager? Now imagine how that knowledge, they've seen the future. The machine learning has told them the future. Of course, it's not 100%. You can imagine how that affects their decisions when they're deciding whether to promote you at a certain point or whether to assign you to a certain task. Well, they already know that you're never going to be vice president. I've not seen this really dealt with sufficiently, but this is what machine learning does. It confronts us with time travel. More and more organizations around the world know your future. They know things you don't even know. They know even when you're ever going to buy your next new car, things you haven't even thought of yet. So we're in a time travel, we're in a time machine. But this is not nitty gritty. This is for the big thinkers of you out there. I couldn't resist raising it. Okay, so here's the outline. I don't have time for all that. Bias in machine learning. First of all, bias is a loaded word. There is irrational bias. There's also rational bias. So let me explain. Let's look at a pattern of decisions. Now, even this way of looking at it, this is a machine learning person's way of looking at a person's decision. This is just a person, the pattern of a person's decision. A loan officer in a bank has approved and denied a variety of loans, and we're looking at this pattern now. Now, before machine learning, it could be that no one ever even looked at it in these terms, looking for the pattern in the data. But let's go ahead and do that. This is a pattern of human behavior. Now, are these decisions biased? Well, they may be. If you look at it, people whose race is X only were approved 1 out of 3, whereas people whose race was not X were approved 2 out of 3, 4 out of 6. So this is the first definition of bias. It's an outcome-based definition. One group is being disadvantaged. Now, this is human decisions. Now, not everyone is satisfied with this definition of bias. The bank certainly will say, well, that's not fair. I wasn't paying attention to race. It just came out that way. I was looking at income or something else. So this allows us a different, weaker definition of bias. We'll only call it bias if you purposely considered race. Well, that's a problem because anyone can claim they weren't purposely considering race. So to summarize, are human decisions biased? First of all, probably yes, in a few different ways. But the topic for today is machine learning, not humans. So the question now is, all right, suppose machine learning learns from people to do like people. Now, are we in a worse situation now? Are we possibly in a better situation now that we have machines learning that pattern of decision from the person? So now machine learning looks at this pattern and learns to be like the person. Okay, so we're in the same situation, same exact situation. Well, we're better. The reason is statistics and machine learning can a little bit begin to tease out what really are the factors that the human was using. He says he wasn't using race, and race correlates with income, but we can use fancy statistical methods, and it's pictured pictorially like this, whether really maybe he was considering race, and even if he wasn't, a certain race was disadvantaged. So the first benefit of machine learning is that, or quantitative methods in general, we begin to tease out what's really going on in terms of human bias. And then as we're building the machine, we can also control whether the machine really implements things that offend us. So we're getting two things at once. By building the machine learning, we're gaining insights into humans, to human behavior, and the quantitative methods allow us a little more control. When we replace the human, we don't have to replace the things that are offensive. So if we do this by machine learning, are we in a worse? We're a little bit in a worse situation because machines can do this on scale. And there's a moral responsibility. No one knows who's responsible if it's a machine. Is it the programmer? Is it the bank? So yes, there is something on the left side of the ledger. In a certain sense, you could say we're worse off. But machine learning has something to offer here. Just the mere fact of the careful quantitative methods allows us to tease things out a little bit. All right, last point. I hope I'll make it in time. Is there anything that machine learning does that's better than just imitating humans or different? Well, there is something. Sometimes we have not data of what the human decided. We have something better or different. We know which person ultimately repaid loans and which person ultimately didn't repay loans or was late or came to be a trouble, defaulted. If we have that data, we call that the truth. Like who really deserves a loan, not who got a loan, not who the human loan officer decided to give approved or not, but who, so to speak, according to the truth, deserved the loan. We can use that to train our model instead of imitating the human. We can learn from the truth. So this is much better. Remember before, this was my slide, that column on the right, the human loan officer approved or denied. We're not going to use that anymore. Instead, we're going to use this data, whether the person repaid on time or not. We're going to learn from the truth. Oh, this is much better because we won't be learning human biases. We'll be learning the truth. Uh-oh. What happens if we learn from the truth that certain races looks like, according to the data, looks like certain races are less prone to repay? Now, of course, we know that that's not the story. It's because those races are discriminated against in their jobs, et cetera, never mind. In machine learning, though, we have the option of learning from the so-called truth. This certainly raises some very intense questions that are different from understanding the human loan officer. That's nothing. Now we have an insight into society. If we have criticism now, it's about society, not about that loan officer. I'm not going to have time for this last point, but it turns out that there is a very enforceable, actionable definition of bias that combines these two ideas: what the decision is and what the truth is. I want to just comment without going into what that definition is. This is an example of it's very sophisticated, this definition. It's very cool, it's enforceable, and it's not prone to, you don't need to know what a person was thinking. It's not one of these psychological situations where, oh, I wasn't looking at race, I was colorblind, I was just looking at something else. This particular definition, which I won't have time for, is neat and elegant and beautiful and is enforceable. Okay, let me try to wrap up. So regarding machines, we have a choice. We can either learn to copy humans, which has its own problems, but it's helpful. We can also learn from the truth, raises its own can of worms, but helpful to raise the conversation. And we have definitions of bias that are cool and enforceable, that don't require endless debate about what a loan officer was thinking. I'm sorry I don't have time for it. Here's a kind of summary. The color things are the good things, what machine learning gives. The statistical methods in general can help us tease out human behavior. Second, machine learning, because forget understanding the loan officer. Machine learning, when we build it from scratch based on the truth, it raises, well, a bad network connection. It raises deep questions, hard questions. And finally, the work in machine learning has given us enforceable definitions of bias. Before I end, last item, I have 30 seconds. The law exists too. Machine learning, the law is fairly nuanced. The law on biases, at least this in the United States, requires that a loan be given to a minority if it's economically prudent. That's a lovely word, prudent. It doesn't mean maximize your profits. It means you must give that loan if it's prudent, reasonable. Machine learning is very flexible in what its objective is. It's not always profit maximizing. Machine learning can work with ethics and work with the law to give it an objective function that gives a loan to anyone where the loan is prudent. So I added that on the bottom to my summary slide. Ethics, machine learning, and the law, not to mention common sense, can work together. I hope I've stuck to my time. I've loved participating. I've learned so much. I got a million notes, and I want to pass it off to the next speaker.